Hello viewers, in today's class we are going to solve yet another important and conceptual problem from definite integrals, right? And here again we have to deal with the greatest integer function, right? So viewers, the concepts in mathematics are very important, right? And once we know the concepts, then we can solve any problem, right? So this problem is a simple one, or we can say this is a very fundamental and elementary problem in definite integrals involving greatest integer function, right? So this is not a hard problem, we can solve it easily, but here we should know some properties of greatest integer function in order to evaluate this integral, right? So let us start. Now here we can take this integral as I, right? Now viewers, here we see that the integrand is sine of greatest integer of x plus 1, right? So here we see that 1 is an integer, and we know an important property of greatest integer function which says that the greatest integer of say x plus m, right? If we have the greatest integer of x plus m, then this expression can also be written as greatest integer of x plus m, right? So this is a very important property of greatest integer function, and we'll make use of this property over here, right? And here we should remember that this x is a real number, and this m is a integer, right? So this is an integer and x is the real number. So in our previous lectures in definite integrals, we have solved the integrals by different methods, that is by method of substitution and by method of inequalities. But here we are not going to solve this integral by method of substitution, right? So here we'll make use of this property. So now using this property we can write this expression as that is greatest integer of x plus 1 can be written as greatest integer of x plus 1, right? Because here m is 1 and 1 is an integer, right? Okay, so now we can replace this greatest integer of x plus 1 by this expression. So now I is equal to 0 to 2, and we have sine of greatest integer of x plus 1, right? Okay, so now here we see that the limits of integration are from 0 to 2, right? So here we have 0, here we have 2, and between 0 and 2 we have the integer 1, right? So what we will do, we'll split this integral as a sum of two integrals, that is from 0 to 1 and from 1 to 2, right? So we can now write 0 to 1 sine of greatest integer of x plus 1 dx plus 1 to 2 sine of greatest integer of x plus 1 dx, right? So now we have to evaluate these two integrals. Now see, here we have this integral can be taken as I1, this integral can be taken as I2, right? Now let us take I1. So here this x, that is x varies from 0 to 1, right? And in the second integral x varies from 1 to 2, right? So from the definition of greatest integer function, whenever x lies between 0 and 1, then the value of greatest integer of x is 0, and similarly when x lies between 1 and 2, then the value of greatest integer of x is 1. So here we'll take 0, and here we'll take 1. So right, so here we have 0 to 1, and we have sine of 0 plus 1 dx, and here we have 1 to 2 sine of 1 plus 1, right? So now this is integral from 0 to 1, this is sine 1 dx, and here we have 1 to 2, this is sine of 2 dx. Now sine 1 and sine 2 are constants, so we can take them outside the integral sign. So we have sine of 1, and here we have 0 to 1 dx, and here we have sine of 2 and 1 to 2 dx, right? So now the integral of dx is simply x. So here we have sine 1 and we have x, limits are from 0 to 1. Here we have sine 2 and here we have x and limits are from 1 to 2. So now we can write sine 1, and here we have 1 minus 0, and here we have sine of 2, and here we have 2 minus 1, right? So this is 1, so we have simply sine of 1, and here we have 2 minus 1 is 1, so we have sine of 2, right? So now viewers, we see that the value of this integral I, it has come out to be sine 1 plus sine 2, right? So this is the value of this integral, right? But we can further simplify it by making some trigonometric transformations. So here we can also write it as sine 2 plus sine 1, right? And if we make the trigonometric transformation, that is we can make use of the result, that is sine of c plus sine of d, right? So where c is 2 and d is 1, so sine c plus sine d is given by 2 sine c plus d over 2 and cos c minus d over 2, right? So these are the simple results from trigonometry which we have to remember. And here we have 2 sine and c plus d, that is 2 plus 1 over 2. This is cos, this is 2 minus 1 over 2, right? So this is 2 sine 3 over 2, and this is cos 1 over 2, right? So we can also express this result as this, right? So these any of the result can be taken as our answer, right? So this is how we solve this important problem.